Good morning, this is your Stats Sensei, Mr. Spensei, and this is our test review. So, baby walkers are seats hanging from frames allow babies to sit upright with their legs dangling and feet touching the floor. Oh, that sounds so adorable. Walkers have wheels on their legs that allow the infant to propel the walker around the house long before he or she can walk or even crawl. Typically, babies use walkers between the ages of 4 months and 11 months. Because most walkers have tray tables in front that block babies' view of their feet, child psychologists have begun to question whether walkers affect infants' cognitive development. So we're worried about intelligence. One study compared mental skills of a random sample of those who used walkers with a random sample of those who never used walkers. All right, so we have two random samples. Mental skill scores. Oh, that must be what we're interested in is mental skill scores. Averaged 113 for 54 babies who used walkers with a standard deviation of 12 and 123 for 55 babies who did not use walkers, and they had a standard deviation of 15. There are more than 5,000 babies who use walkers and more than 20,000 babies who do not use walkers. Is there evidence at a 1% level? All right, so we have an alpha here of 1%. And that because of that, I know that we're running a two sample because we have two samples, and we're going to be running a hypothesis test as opposed to a confidence interval because they gave me an alpha level. Because they gave me a significance level, I know it's a hypothesis test and not a confidence interval. All right, so let's get to it. Our parameters. Well, we have two. We have the walkers and we have the let's see if I can get that to focus better. All right, we have the walkers and we have those that are not in walkers. So let mu1 equal the true population mean, that does not look like mean mental skill for babies in walkers. All right, so that's mu1. Well, boy, we're having trouble with focus today. Let mu2 equal the true population mean mental skill for babies not in walkers or without walkers. All right. The null, it's always easy. It's always equal. So mu1 equals mu2. Those in walkers have the same mental skill as those who are not in walkers. I'm going to try the blue pen and see if that shows up a little better since we're having trouble with the focus today. HA, mu1 and mu2. Now we need to figure out what our inequality is. All right. And we want to see uh, typically, where is it? Child psychologists have begun to question whether walkers affect cognitive development. One study compared mental skills of random sample of those who had walkers with those who never used walkers. Is there evidence to claim that the mean mental skill of babies who use walkers is less than? That's what we were looking for. Sorry about that. Sorry, that took a little bit of time. So mu1, the mean mental skill with walkers, because this is the walkers, this is without the walkers. See whether or not it is less. Well, our formula is T equals X bar 1 minus X bar 2 over S1 squared in 1 plus S2 squared in 2. So the sample mean for those in walkers, sample mean not in walkers, standard deviation sample standard deviation in walkers and sample size of in walkers. The standard deviation of babies not in walkers, standard deviation, and the sample size of those not in walkers. So let's look at the sizes. All right, so we had 113 mental skill for 113 for those who used walkers. So they had 113, and it said that they had a sample size of 54 with a standard deviation of 12. The other group, those who did not use walkers, had a mean of 123. There were 55 of them, and they had a standard deviation of 15. So 123, 55, standard deviation of 15. And if we look at our alternative hypothesis, we said less than. All right. Because we're working with random samples, we're going to have to do all the conditions this time. We don't get to shortcut it. So they told us both samples are random. And that was given to us. So we don't have to do anything with that. We can just check it off. Number two, we have two independent samples. Two independent samples. And that was also given. So we don't have to do anything with that. Now we need to do the n is less than 10%. And we're going to have to do that twice. We're going to have to do that for sample 1 and sample 2. So sample 1, oops, I made a switch here. That's got to be changed. This was a standard deviation of 12 and a sample size of 54. There we go. That looks better. So N1 equals 54. And we're going to take 54 times 10, and we get 540. And what was that population? We said, oh, there are more than 5,000 babies who use walkers. So that's 5,000. And that's less, so we're good to go with that. And then for N2 equals 55. And so we go 55 times 10, and that's 550. And we had a population of 20,000, and that's less than 20,000, so we're good to go there. All right, number 4. We need to check normality. N1 equals 54, and N2 equals 55, both greater than 30. Approximately normal by CLT, by central limit theorem. All right, so we need to start plugging our values into our formula. And remember, we have a less than, and so it'd be like this. The probability that T is less than, well, a sample mean of 113 minus the 123 over sample standard deviation of 12, so 12 squared over 54, plus 15 squared over 55. All right, let's get the calculator out and start plugging that in. So, stat, test. We're only dropped down to number 4, 2 sample t-test. And we're highlighting statistics. X bar 1 is 113. X bar 2 is, so then it asks for the sample standard deviation. Sample standard deviation was 12. And we had a sample size of 54. The sample mean was 123. We had a sample standard deviation of 15. And we had a sample size of 55. And our hypothesis was less than. So let's see what happens. Oh, and we never pool. We calculate, and I get a pretty large t-value, very negative, and a pretty small p-value. So my t-value is we're looking for the probability that t is less than negative 3.8468. Now remember, you can never have a p-value greater than 1. So if it looks like it is, then start looking for zeros. So in this case, we're going to have 3 zeros in front because it's always going to be 1 less than what they have. So we're going to have 0.0001. Technically, I could write 0.00010389, but I only go 4 places, so that's a pretty small p-value. So my p-value is 0.0001. When we were reading, it wanted us to use a significance level of 1%. So our alpha is 0.01. If I make that 4 decimal places, I see that I have 100, and 100 is definitely larger than 1. So this is less. So my decision is to reject the null. And by rejecting the null, I'm saying that there is a difference in, I'm saying that the mean mental score for those in walkers is less than those who are not in walkers. So let's write this up. Our p value is 0.0001. We reject the null. There is plenty, there's enough, there's sufficient evidence at alpha equal 0.01 to suggest that this is where it gets a little bit different. The true population difference of the means for the mental skill for babies and walkers is, what was our alternative? Less than the mental skill for babies not in walkers. That's a lot of writing. So basically, we restated our alternative. We said it's less than the mental skills for those in the walkers. Mental skill for babies in walkers is less than that for not in walkers. And that's what we had here. Mental skill for babies in walkers, because that was mu1, is less than the mental skill for babies not in walkers. All right. I hope this helped. Hope to see you on the next one. Study for your test.